There's one final way that you could possibly see this, um, and this is in the event that what if they give you the radius, um, but they do not give you your apothem or perimeter, and you're still asked to find for the area. Okay. Now, a radius, when we use the term radius, we usually refer to a circle. And you don't see it here, but you need to imagine it. Okay. If this figure, okay, was inside your circle, right, such that the vertices of the figure touch the circle. Okay. Again, I'm going to do my best here to draw such circle. So I don't have a compass on me. But here we have our circle. Again, it's not perfect, but I hope that you can imagine it. And so this black dashed line here goes from the center to the edge of the circle. Okay. So again, if I'm not mistaken, this is referring to circumscribed figures, basically. Okay. Circumscribed, inscribed. Which one is it? So let me actually look that up really quick. What is this called, actually, right? So if I look this up really quick, circumscribed polygons, and that's going to tell me if this is what I'm talking about. Versus inscribed. Okay. All right. So hopefully this shows me it really quick. I don't want a video. Really quick difference. Oh, right here, perfect. All right, so circumscribe versus inscribe. Okay, so here we're actually dealing with basically our figure is circumscribed. Yes, the figure is inside. Okay, so perfect. Okay, perfect. Okay, okay. All right, so that's what we're dealing with, right? And so since this is circumscribed, we have our radius right there. So again, please understand that when we connect to a corner, any corner, whether it's in a hexagon, whether it's in an octagon, or in a pentagon, okay, if you're connecting to a corner, quote unquote, that is your radius, okay? All right, so let's get started. I'm going to show you how to solve for the apothem and the perimeter. Very similar to what we did before. So let's just say that in this hexagon, my radius was 10. I'm going to do honestly the same thing with the angles, okay? I'm going to find the angle so that I could focus only on that triangle right there. So once again, I'm going to do 360 divided by the number of sides. So 360 divided by, in this case, 6, right? So that gives me 60. I'm going to have to divide that by 2, so that gives me 30. So again, notice how this trig part plays an important role and how important it is to know it. So at the end of the day, basically, I need to find my apothem, and I'm going to have to find my half length at some point. So I'm going to call that x. And I know that this angle here is 30. Again, it's very important you know where this goes, right? Look at your picture. So this has to be 60. And now I just do a quick law of sines relationship. The 10 is with the 90. Let's say you wanted to find the apothem first, right? The A is with the 60. So I wanted to find the apothem. I do a quick 10 times the sine of 60. And again, I want to remind you guys that the sine of 90 is just 1, okay? But I'm just going to write it down here as normal. So my apothem is actually 8.6 or 8.7. I'm going to go ahead and round, okay? Let's say you were solving for your x now. You could use the same 10 sine of 90 relationship. And the x is with the 30. Now I know I put it right next to it, and you could totally do that. All you have to do is just pretend that that wasn't there, right? And you do the same type of calculation. You cross multiply. So right there, it is 10 times the sine of 30 now, divided by the sine of 90. And so each side length here is 5. I mean, this part is 5. So if that's 5, that's 5. So each side is actually 10. And now that I know that each side is 10, I could easily get my perimeter. Oh, my perimeter has to be 60. And again, once you know those two things, you're pretty much set and ready to find the area. Go back and look at part 1 if you don't know what to do with those two things. All right, next one. And again, it's the same thing. It's just a quick law of sines, and that's all it is. If your radius, if I told you that this was, I don't know, 8, and I don't know if some of you guys are thinking, sir, is your radius and your side always the same thing? Well, that's what we're going to do a few problems and see if that's the case, guys, okay? So, number, on this one, on the octagon, let's say that was 8. So again, same thing. We start off with the angle. Sorry, guys. Go ahead and find the angle, guys. Put pause and put play right away. All right, so go ahead and put pause. All right, so let's see if we were able to get the angle correctly. So it's 360 divided by 8. That's 45. And again, we have to divide it by 2. So that's 22.5. So when we draw our right triangle, I know this is 8. The angle right there is 22.5. I need to find my apothem, and I need to find my half length. But I'm going to do the same thing, right? The 8 goes with the 90. Let's say I wanted to find my apothem first. Well, the angle across the apothem, I don't know it at the moment, but I could easily calculate it. It's 67.5. And again, I do a quick calculation. 8 times the sine of 67.5 divided by the sine of 90, which honestly is just 1. Okay, but here my apothem, I just found out for it to be basically 7.4. If I want to find my half length, again, x is to the 22.5. And again, all you have to do is just, pretend that part was in there, do a quick cross multiplication, go back and look at the video on law of sines if you forgot. Oh, and here, guys, make sure you put that it's the sine of 22.5, okay? Don't forget the sine. So 8 times the sine of 22.5. But yeah, go back, guys, if you're still having a hard time using this law right here. Or reach out to me. I'll show you Sokotoa. Maybe you prefer that one instead. So each little side length here is basically 3, okay? And if that's 3, that's 3. Remember, we just have to multiply it by 2, okay? So each side length is 6. So that means that our perimeter, in this case 6 times 8, is 48. And again, the moment you find those two values, everything is super easy. The last problem I have here is a pentagon. And again, I'm just having you guys noticing that the only thing that changes is the angle, but all the steps are exactly the same. So again, we're still gonna eventually see this right triangle. For now, let's just say that this was, I guess 10, just keep it simple, okay? And again, we start off with the angle part. 360 divided by 5, yes, that's 72. And then we have to divide that by 2, that's 36. We know this is 90. Where will the 72 go, on top or towards the bottom? And I mean the 36. The 36, does it go on top or in the bottom? Yeah, it goes on top here, right? So that's 36 degrees. We're looking for our apothem and our half side here, and we know this is 10. And we do exactly the same thing, right? Put pause really quick. Do your quick wall sign setup. Go. All right, we're back. So you guys must have done this whole 10 and to the sine of 90, okay? And if you're looking for your apothem first, you must have already found the angle, and you found out for it to be 54, so sine 54. And eventually you did the x one as well, and you did it to the sine of 36. So when you guys were solving for a, you must have done 10 times the sine of 54 divided by the sine of 90, right? And so our apothem was pretty much 8.1 if you want to, you know, get a little closer. And the half side length, right, is 10 times the sine of 36 divided by the sine of 90. But again, please remember that the sine of 90 is just 1, so you really don't have to do this part, the division part. So the half side length is 5.87, so I'm just going to round up and say it's 5.9. And this is, again, just half, so you're going to have to multiply by 2, okay? And so when we multiply by 2, we basically get that each side length is 11.8, okay? And so if I wanted to find my perimeter, it's my side length times the number of sides, in this case 5, so the perimeter is 59, okay? And so that's it on this last part, guys. That's it on area of regular polygons, okay? Next up, obviously on the next lesson, I'm gonna go ahead and merge everything together. So it is very important that you guys can find the area of each individual shape, so that you can ultimately solve the more challenging problems, okay? Thank you, guys. Again, if you have any questions whatsoever, please reach out to me. Okay? Bye-bye.